Well, let's take a look at number 10. This is from the first practice exam that's posted. This question confused a lot of people last year. I remember this one when we gave the exam. Okay, 20 centimeters. Silly question. That's only one sig fig, according to our sig fig rules. It's not two. It's just one sig fig, good to the tens placeholder. So when we add that to 1163, which is good to the ones placeholder, that value is only going to be good to the tens placeholder. Like I said, really tricky because you may have thought that was two sig figs and may have thought this value would be good to the threes, but it's really just good to the tens placeholder because 20 would be assumed to be only one significant figure when written out this way. So if we don't have any information about that zero, we're assuming only the 2 is significant. So the zeros are only significant when they're after a decimal. So if we were at like 2.0 centimeters and saw that in a problem, that would be two sig figs. But if we saw something like 200 centimeters, that's also just one significant figure. Okay, and so then we carry out the next step, and we're doing a subtraction. So it's counting sig figs again, or counting placeholders again. So this value is going to be good to the, once we do the subtraction, it's going to be good to a total of 5 significant figures. See, I don't even have to really do this step here because I know it's going to be 15.1, something, something. Then we're going to round the value off to the third decimal place. The only reason why I'm shorthanding it at this point is I have 5 sig figs clearly here. And I'm going to multiply that by 3 sig figs. So the result should have 3 significant figures. And there's no choices on the variation of what the actual number might be, so I didn't bother actually finalizing the actual calculation. But if we do the final calculation, we should arrive at that particular value. Okay, so the key here, if you thought it was 4, you probably mistakenly thought 20 had 2 sig figs. I can understand why you would make that mistake. It's a weird number to have in a problem like this, but that would only be one significant figure. All right, let's take a look at number 9 here. We have 5.75 grams per milliliter plus 45 plus 75. We add those two numbers together, we get 80 plus 40, so it's 120 grams. Now, how many sig figs does that have? Now, previous problem you may have said, well, before we had 20 centimeters, you said that was one sig fig, but we didn't know where that zero came from. We're just seeing 20 centimeters written out, so we assume one sig fig. Here we've done 45 plus 75, added them together, and got 120. Now we know where that zero came from. It came from a ones placeholder that was known precisely and another ones placeholder that was known precisely. That means this number here has 3 sig figs. Okay, and so then we're going to divide that by 3 sig figs. And we're going to keep all 3 sig figs for this calculation here. So we carry out that step. That works out to be 3 sig figs. Okay, now this is going to depend on what the number is. So we actually have to work this out. So if I take 120, divide by 12.5, that works out to be 9.60. To 3 sig figs, all 3 being significant. Then if I take a value to the hundredths placeholder plus the hundredths placeholder, the final answer has to be good to that same placeholder. So when I carry out the addition step, I get 15.35. And I know that 5 is significant, so I have a total of 4 significant figures in the result on this problem here. The key here is 120 grams per milliliter here, or 120 grams is good to 3 sig figs because we know where that zero came from, and we know it's now significant having followed the rules of sig figs for the addition step there.